right? So I love the old movies and how they used to play the credits at the beginning, so I started with that. So I'd like to say thank you for all the people in high places that still allow me to travel unmolested and speak freely at conferences. So thank you. So I'm the AG from AG Projects. 32 projects to be more specific if the metric is counting repositories that you authored on GitHub. There are other metrics, but this is something that people seems to look for nowadays. So I promised that 33 will be my last project, but will I ever stop? Actually, I don't know. Hello? You missed everything. Okay, so I'm supposed to talk about SIP clients in the open source domain and beyond. But, well, I'm not going to trash my competition, and what do I know? I'm going to speak about my SIP clients. I have a suitcase full of them, so let me show it to you. So they tell you that it's good to know your audience, so you should relate to them, so I'll ask a question. How many of you are using a SIP client, a SIP software client on a daily basis during your office hours? Well, quite a few. It's not like the drug dealer conference where we just distribute stuff and we don't consume it. That's good. So this is the first VoIP client that I have ever used in my life. It was, and still is actually, it's politically incorrect nowadays, named Software Speak Freely. Speaking about minimalist user interfaces. Today I use Silk Desktop, which is my last SIP client. This is, how can I put it? I had to write it down. It is a web page containing JavaScript embedded into an Electron sandwich exhibiting a SIP interface through a Janus media server proxied by a software written in Python called Silk server. So do I have any excuse for this? Well, let's check it out. So when I started my business, also SIP protocol started, but I didn't know about it. So I was doing managed DNS, naming and addressing for the internet era. And I was wondering if there's any hardware that allows me to talk to my coworkers, like Speak Freely, which was a software on Windows. Is there any hardware that can just plug into the Ethernet and make a voice over IP call? And well, there was. I discovered this CBIT in Hanover, in Germany, back at the time when Germans had gas from Russia and still an economy going. They had these wonderful SNOME phones. And, well, it was an amazing thing. It has Linux inside, a web server, a multi-account, TLS. It was well ahead of its time. I really loved it. So much that I wanted to know its maker, so I went to Berlin. So I met Christian Stredike, and he explained to me that a SIP client cannot be any better than its server counterpart. SNOME had also a PBX they were selling per seat. But this was an interesting observation that the client worked so well because they had a server that did a lot of stuff behind the screen. And then the voice over IP revolution started, thanks to Von and IT Expo and others. But that was not enough. These guys had to appear in order for the money to start being poured into this industry. Skype came, and this was beautiful. A piece of software that works on cross-platform on any system, and it does voice calls, video calls, chat, file transfers. What a beautiful piece of software. And I said, I want to build a software like that, but with SIP protocol, because I like open standards and open source. But what did I know at the time? So in order to do that, as Christian explained, you need a good server. So where is that server? I discovered this server, which was a new project at the time, Fraunhofer Institute in Berlin, which was run by a Romanian, like Henry Sinreich, who ended up to be my mentor. We're all from the old country, and we all wanted to see this developing further. And this project was basically the start point for a lot of servers in the open source domain, for SIP proxies and registrars. And because of the Romanian heritage, that's why a lot of Romanian students from Bucharest were teleported to Berlin, and that's how VoIP Romania Mafia was born. So they say in order to be successful in life, you have to be the first, be smart, well, or cheat. This is from a movie I watched recently. Well, it's not true, because if it's about Bitcoin, you don't want to sell your Bitcoin so when they're $199, believe me, and I did that. So I was not first doing a SIP client or a VoIP client or a server. So I said, let's be smart. So I did what Mark Spencer did. Well, rebranded a bit, repurposed a bit. So my managed DNS platform became multimedia service platform, a SIP-enabled telecommunications platform. And guess what? In no time, the second largest telecom operator in Germany purchased the platform. So I was on a good path. So I learned early that it's good to contribute to open source. Somehow, even if you give things for free, they come back with a vengeance with a lot of money back. So I made CDR2, which was the first CDR mediation rating engine and prepaid engine for SIP Express router. If you haven't written servers in PHP language, believe me, it is possible to listen on a socket and serve requests like this. It still works today, still going strong. I don't know why. It's like a sticky piece of software. Then we contributed to NAT traversal module used in SIP Express router and all variants after it. We developed the first scalable distributed media relay there was at the time. So you could run media proxy on multiple machines driven by the same SIP proxy. We're doing enum like there is no tomorrow, not that anyone needed it. We thought it's a big deal, but in the end, nobody wants to put their numbers in the public enum tree for sure, though I did for 3 countries. However, carrier enum, it's something else. Everyone is using it in one way or another inside their garden, because you need to map telephone numbers into SIP addresses somehow, and enum is probably invisible under the hood, present everywhere. My mentor was also working on this wonderful book, SIP Beyond VoIP, which became the inspiration for all the work I did afterwards. So SIP Beyond VoIP, what does it mean? Well, SIP was not designed with the idea of having a VoIP or a voice over IP call only, but to do, well, to allow the rendezvous of endpoints and let them negotiate whatever they want to negotiate. And Skype was a good example. So you could do chat, file transfers, screen sharing, presence, a lot of features that, well, in the SIP world, they didn't happen yet. So, well, as I said, all these features that were missing, practically chat presence, contact management, file transfers, conferencing, all these missing pieces, if I ever attempted to build a client, I needed a server for them. So I set out to implement these missing parts. These are practically deliverables of the IETF working group, and they standardized 2 new protocols, XCAP and MSRP, and our company over time implemented everything client and server related to these components, which practically complemented the existing SIP signaling and RTP and all the other things. So with this, finally, you had a complete, Skype-like functionality on the server and client side. Something else was happening in 2005. Internet was scaling up. All these companies that really went gigantic in scale, like Amazon, Skype, Google even, they didn't put a load balancer in front of their 2 servers or 3 servers, right? So they found a different way to scale up. And I did the same. In 2005, I was the one who built, well, the first Beyond carrier-grade SIP platform product. It would scale horizontally with the amount of hardware, with no standby component, all active mode, all distributed, and no single center point of failure. This was so amazing that the prospect customers I presented this to, they said that you're crazy, Adrian. This can never work. Even if it is working they could look at it working. So KPN and Deutsche Telekom said, Adrian, we have a roadmap of 10 years to do this, and you're already here. So what shall it become of us? Maybe Skype will buy it or somebody else, because we need 10 years to work on this. We don't want to be ready today. So, well, there were others who bought it, and believe me, it's a beautiful piece of software. This is not in the open source domain. This is the core of our company. This is the main product we sell, actually. It's a way to scale up any resource, whether it's signaling, media relay, billing, accounting, provisioning, you name it. If you want to scale up horizontally with the amount of hardware per function, we have an abstract software that can do exactly that. In our case, we applied it to our own platform and to our own design, but the software is generic, and it's such a clever software that can be applied to anything without having to change almost nothing. So with it, we built sip2sip.info, which was, at that time, was the second service. Iptel, I think, was the first one to offer a free SIP account. Still going strong today. If you don't have a SIP account, you can register one with sip2sip.info. You can see nicely how scalability through SIP-Tor lens is seen. So all the load is distributed equally across the SIP proxies and the media relays. So I already had some pieces that, like Skype, I imagine, in order to do Skype, you need to have an infrastructure. You need to have a server side. So it was like the time where I dared to say, well, why not build a SIP client now? So I had a blueprint, and the blueprint was, well, it was in the book written by Henry Sinreich, and there was nothing missing except that I faced the same question that the Asterisk project faced 10 years later. Which SIP stack shall I use? Well, I was lucky in 2006. I met Benny Prigioni. So in Cambridge, I met him, and he told me an amazing story. He said, Adrian, people in Indonesia are building SIP stacks for thousands of years. Well, he said that you cannot compete with this. So I said, if you can't beat them, let's join them. So I solved this little piece of the puzzle. And also I had the chance to learn early that encryption should be end-to-end, and I learned this directly from Phil Zimmerman. He said, Adrian, ZRTP, if you don't do ZRT, I'm not going to talk to you ever again. So okay, finally, there was nothing else missing. We had the servers, we had all the pieces in place. So in 2007, we produced the first version of what is today called SIP Simple Client SDK. This is a software written in Python, so if you make the choice to use it, it limits your choice based on the programming language. However, if you like Python, you can use, even today, this software to create any type of SIP and beyond SIP functionality on desktop systems, namely Mac, Linux, and Windows. This is SDK with a lot of features. Basically, all the SIP Simple working group deliverables are inside. You can do audio, video conferencing, chat, file transfers, you name it. And again, this is a building block, so you can use it to build a client with it. It's not a client, it's an SDK, which gives you the primitive to forget about the little parts like multiple account management, settings, all kind of things that you need to build when you have a client. You have high-level APIs in Python for all these things. So it is cross-platform. Well, as cross-platform as it was at the time, in the time when Symbian was running the mobile world. All the software we make is typically packaged for Debian and Ubuntu in a Debian format. Our website package is agprojects.com. If you just go there, you find the list of packages. In this case, it's called Python SIP Simple. So if you want to install this SDK, it's as simple as following the instructions on the website. Now, this is the first SIP client ever built on top of this SDK. I haven't seen it. I was told it flew somewhere in Buenos Aires at a conference, but the technology was lost. Well, also NASA lost the technology to land on the moon if we ever been there. So I'm not the first one. Second incarnation or second usage of the SDK were these command line interfaces. Command line interface tools, command line clients, which are very interesting for those who work basically in a terminal, like we all do. You need tools to test, and you're curious to, like the speaker before me, he was mentioning these end-to-end testing tools. Well, here is one for you. With these tools, you can, for instance, auto-answer in 3 seconds, auto-hang up in 10 seconds. It's a one-liner script, and you can configure it in all kind of crazy ways. You can only accept video calls if you want, or reject, I don't know. There is various criteria, and it's all in the command line. It's very easy to use. So if you want to test your server after an upgrade, if you're curious if your call transfers still work, or whatever function that is in the SIP protocol, we have SIP command line tools that with just one-liner can achieve this. So try it out. 1 year later, we went to test our SIP stack in Japan, not SIP, but everything else. We went there was nobody to test against, of course. I mean, people were struggling to make a proper DNS lookup. We could already add 4 M lines there. So, but it was nice to be in Japan, okay? So, well, the Tandberg terminals around us were getting nervous. I mean, our SDK was really, it felt good. But then something else happened. Remember Skype? I keep talking about Skype, right? So in 2005, Skype was basically sold for like $2.6 billion. eBay purchased it. And the lady who signed for the deal did not actually buy the intellectual property of Skype. I don't know. So 4 years later, they wanted to sell it to a group of investors. The founders of Skype say, no, you can't sell it. It's our software still. Oh, God, what do we do? So they set up, actually, to rewrite Skype entirely in SIP, to make a SIP client for the client side and the SIP server for the server side. So they went and hired all the bright engineers at ITF that were waiting in line for the microphone, hired them all. It was a big hiring spree. And for the server part, well, guess what? They called me, said, Adrian, seems that you are the only guy who already have this working, so please work with us. We need your help. Well, of course, I'm ready, but, well, not so fast. The lawyers decided it's cheaper to fork $2 billion more to the original founder and get over with it. So the moral is engineering doesn't pay very well. Better study something else. But now I was finished, so I had no other things to do. So finally, I produced what I thought it's the competition to Skype at the time. I produced Blink for Mac at the time, using, basically we call it Blink Cocoa. It was the first SIP client written in the native Mac, whatever language it was. It's using Python underneath, but then Cocoa had bindings for it, so we could produce a native application on Mac. It was easy to configure, and this is what I learned from Skype and also from others. Just user, domain, and password. Why do you need to type all those 50 million little things like port numbers, protocols? Nobody got it right. I don't know why. You should just put user, domain, and password, and it should just work. The reason it doesn't work is that there was a lack of understanding or the need for the use of the DNS. With DNS, you can discover where the server is, which protocol is using at which port, and so forth. So if you properly implement RFC 3263, which is mandatory basically for SIP, you would find your server and just provision your users much more easier. You could dial with Blink any SIP address or telephone number. It will look up the number properly or the SIP domain properly, and it will find the SIP proxy. Addressing a number is key, so your user experience is pretty good. So the software had already at the start features beyond VoIP, namely had chat using MSRP protocol, conferencing both client side and server side. It supported both. It had file transfer. I think we had screen sharing later, but we were having 3 M lines, so I was very proud of that. But everyone started being mad. Adrian, where is the dial pad? Where is the dial pad? This is a VoIP client. Where is the dial pad? I said, no, it's not a VoIP client. It's a SIP client, man. And the dial pad, I mean, the keyboard is there. It's just hidden under the hands of the operator, you know? Why do you need a dial pad? Well, we need a dial pad because we need a dial pad. Okay, so I made the pro version. I put it in the App Store. Here's $29.99 if you want a dial pad. Another problem solved. Then we brought out Blink for Linux. This was written from scratch using Qt, another framework, which was available for Linux at the time. So basically, this is another SIP client altogether. It doesn't share the code base with Blink for Mac at all. Again, it had features beyond VoIP at day 1, but less than the Mac version. And we got also the Blink for Windows version for free. Well, for free, not for the users, it was for free. It was for free for me because I didn't have to pay to make yet another Windows version of it. Qt was cross-platform enough, so I don't have to rewrite it. So for me, this was a client made for free. It didn't cost me extra money to make the Windows version. And we had encryption, end-to-end, for all media, which nobody had at the time. So you had ZRTP for audio and video. You had OTR for the chat established over MSRP protocol. And you can learn one from the other, so you didn't have to, once you had a ZRTP call set up, you can reuse the same to pass this trust to the text chat stream, for instance. So it was very easy to set up and keep going. But does encryption work? Because everyone is curious. How good is your encryption? How? Well, there are all kinds of tests for encryption to detect whether it works or not, but the only test it is, if you ask me, is the following. If two secret agents of the intelligence services of your country ring at your door, if your wife is pouring coffee and the elderly of the two officers says, would you put a backdoor into your software, then it means encryption works, right? Others, they wouldn't bother to be there. So that was the test, and I passed it. Well, I didn't put the backdoor. I prefer to take the boat, and I change basically my location. I moved to South America, which is pretty quiet, nothing to do there, really. It's just enjoying life. But I kept going, so I wanted to go mobile now that it was iPhones and everything. But how do you go mobile with Python? No way, Python doesn't work on a mobile. The OS doesn't support you. Nobody supports mobile on Python on a mobile. You want to do video conferencing? How to do that with SIP? SIP was too early. It was the first. Didn't yet know about these things. So for this, well, as for everything else, you need an adapter. This is where WebRTC saved the day, because it didn't displace SIP. Rather, it complemented it. So for us, it meant we have to build yet another server. Because no matter what, you have to build a server. If you want to make a client, first you have to build a server. So we started building Silk Server. This is still ongoing after 10 years. This server has all kinds of important features that are not supposed to displace or replace anything like an asterisk or OpenSIPs or anything. It's something complementary. It may work for anyone who already has a SIP infrastructure perfectly. So it's not supposed to replace anything. It's an addition to whatever you have. I'm sure there are functions here that your infrastructure doesn't have, especially related to push notifications, messaging, file transfers, all kinds of features beyond VoIP. It requires a SIP server to operate. So it is a SIP server as well, but it requires a SIP infrastructure to properly operate, meaning authenticating users, doing NAT traversal, and all the things. So this Silk server, it's like an asterisk behind, let's say, a SIP proxy server. The nice thing about it is that it's zero configuration. You download it, you start it, everything works. You don't have to configure a thing unless you really know what you're doing. You can really do a lot of configuration, but the idea is that it works the moment you download it, it works with no problems. Now, on top, in order to use the server, you need an application programming interface, and once we migrated towards JavaScript, then sky was the limit then to build whatever you want and go mobile, for example. Yeah. So once you have a server, the server is written in Python, but you have a JavaScript API for it, something you can embed into the device you want to develop on, then it's very easy to create applications. And this is not anymore a SIP client, actually. It's on the server side, looks like SIP, but inside is just JavaScript. And you use the WebRTC to have access to all the media codecs and the whole thing that, for example, Chrome engine offers to you. Then use the API, and through Silk Server, you look like a SIP client, but you're anything but inside. So we created this cross-platform, much easier than we have done previously. It was much faster, but it looked differently, and webbish. It looks unnatural, looks the same on every platform, but it looks non-native everywhere. So this is the disadvantage of using these web technologies. They all look in a certain way, but not native for sure. Then we even went mobile. In 2016, we managed to get the first call through a mobile. For me, it was like, wow, I thought you need 100 engineers for that, but we did it. It was a prototype, of course, but it was possible. But soon we learned that you can't get a call because you can't receive calls on mobile because you need to wake up the goddamn software which is sleeping there. So registrations are useless. Your software is being killed by the OS. You can't do anything that you normally do on, in the normal world. So yet another server missing. Go and implement that. So we did Silk Push Server. Take a look at this. Whomever does anything with mobile, you need something to talk to Apple and Google to send the goddamn push notification. And if you have 20 apps and 20 servers and different things, you need an API and properly structure all this mess. And with this, you get rid of this little task: how to organize sending your push notifications for different type of applications. With Silk Push Server, you can do this very elegantly. You can define your applications and your keys and everything, and you have an API for it that you can call from your server to send these notifications very elegantly. Then we had to migrate all this software. As you see, years have passed. Python 2 was phased out, so we had to migrate everything to Python 3. Which we did, so everything is up to date on Python 3 nowadays. Everything works. So we maintained this, this SDK because, as you see, it's not only good to make SIP clients, but SIP servers as well, and application servers that are used for SIP. The command line clients are much, much better. You see, the terminal is much larger and much higher, so it becomes better and better. So if you So now everything has the 3 suffix. So if you do apt-get install, just add a 3 at the end. That's the Python 3 version for everything we have created. So those who like to live in a terminal can continue living there, like Tom Hanks. So our current roadmap and our effort in the last couple of years was directed towards messaging. Right now, we are proud to have messaging almost on par with Telegram and WhatsApp. We have everything what it takes to make synchronization for multiple devices, offline messaging, all end-to-end encrypted using PGP. So you have a journal that per client keeps track of all the messaging things, and you can delete conversations, individual messages, you can get read receipts, confirmation for all the operations you do with your peers or with your other devices. Everything very easy to use, just take a look. We're still working on it, namely we don't have features related to group communications, but for end-to-end messaging, we have practically completed our internal roadmap. So apt-get Silk Server WebRTC Gateway will basically get you the software to have all this functionality at your disposal. And of course you have to check the API, how it works, but once you have this in place, it's easy to develop something to add it to another application you may have already written, another client or a WebRTC client or a SIP client. There is APIs, both in JavaScript and for SIP, so that you can get the same functionality on a pure SIP endpoint that supports SIP message method, or you develop a web application with the JavaScript API. Today we have Blink for Mac, which also supports all these features. So you have messaging, which uses this API with all the functions I mentioned. Blink is still good at what is originally what originally was designed for, to do client-side conferencing, but can do also server-side conferencing. It's very easy to do drag and drop with these tiles, and you can create as many conferences as you want and switch between them. These are the codecs we use today. Everyone loves codecs, right? For us, wideband is a must for everyone nowadays, I assume, but this is, we did this from the start, but we added some new codecs here. I'm curious if anyone is using AMR. I don't know why I added it there, but they say in the mobile world they want to use AMR wideband, so okay, I put it there. Maybe there will be an interop later on. Does anyone use AMR? Nobody. Well, that's the answer. This is the list of current codecs, and probably it will keep shrinking in the end. The idea is that you have just one and no more a forest of codecs. These are features related to the messaging, which are supported in the API I mentioned. OpenPGP, replication, the IMDN messages to, to confirm whether you have read or delivered a message, whether we use this composing or not. This is all done using classic, we made SIP message method great again, because my company was MSRP based. MSRP, nobody's using MSRP. But I did it anyway, because it was part of the SIP Simple working group, and I loved it. But the reality is that little messages can do more than SIP sessions, which are like limiting the way things work. MSRP is not good for synchronizing multiple devices. So it was a strange thing, this MSRP. So I don't know what to say. I returned to SIP message method, to be honest. The reality is that the problem was blocking. Things were blocking, still they are in SIP proxies and even asterisk, as Joshua mentioned. You have to be careful with all kinds of things that don't block. And TLS was a problem for a long time. You don't want to have your messages, unencrypted over the network in a SIP payload. Now you have TLS working and non-blocking. Finally, you can properly use SIP messaging with TLS. But when we were starting, you could not use TLS because SIP Express router will just choke on it. So this came later. So now we can do SIP messaging properly using TLS. And then the payload itself is encrypted with PGP. So you have a pretty good stack of encryption there. This is Blink, the native interface doing multi-party conferencing, which is, again, is based on the IETF SIP Simple working group server-side functionality, no video. So we could not go anywhere with video on the SIP, pure SIP client side. To install the messaging server, it requires also that your SIP infrastructure is ready for it, because it requires a lot of SIP moving parts. If you want to synchronize messages across multiple devices, you need proper parallel forking. Silk server has to be involved. You have to fork to it. It's quite something. If you follow our recipe, again, it's a zero configuration thing, but you have to use OpenSIPs the way we configured it. Everything is prepackaged. However, if you read the config and you understand it, you can port it eventually to your SIP server of your choice. Again, Silk server requires a SIP server to operate. So it can be your SIP, any SIP server that can fulfill those functions, which is just basic parallel forking, authentication for a register, and has the capability to configure what happens to various payloads, right? So these features that exist in the server, the journal I mentioned, you need to store all these messages, and we have two types of storage engines. The one that works with zero configuration is just a JSON journal, nothing to configure, but if you want scalability, we support Cassandra, which itself is distributed, so you can have resilience on the storage of the messages for your end users with Cassandra. Works very well. So this journal keeps track of the messages for each user, also for the files. You can do file transfer as well. Again, distributed, replicated between devices. You have the APIs for both SIP and WebRTC for this system, and mobile push notifications. So you are not stuck when it comes to mobile. So everything is there. Again, zero configuration. If you download it, you'll see, okay, so what now? Well, you have to look at the sample clients that are also open source. How do we make use of those interfaces? But the server, it's very easy to use because it requires no advanced configuration or understanding of anything. So this is Blink Qt for Linux right now. It has the same feature set, namely the messaging features are compatible with Blink for Mac, also with Silk client for desktop. So you have it's a nice thing. If you can't achieve interoperability going to Japan, you can at least achieve interoperability between your own SIP clients. So I managed to achieve that here. I can send a message from Linux, from Blink Qt, and I can receive it on Mac with Blink Cocoa, or send it to the web page in Safari, and it works. Now, the good thing is that the latest iteration of Blink Qt, which is using Qt6, is now fully cross-platform, including for Mac. I suspect at some moment in time, Apple will not allow us to develop anything written in Python to produce it from Xcode. So for this reason, we put some effort into making sure if the zip client is supposed to survive, that also the Mac users will have an alternative. So right now, the Qt version is working on basically all 3 major operating systems for desktop. Same for Windows. Basically, Windows version was dead for a few years. Nobody cared in our company about it, to be honest. And the clients didn't ask for it, but it's back. So Blink for Microsoft Windows, it's on par with all this feature set. Now it works on Windows. As far as I know, but I haven't tested personally. So people that asked, they said, yeah, it works, Adrian, but I don't know what I tested. So if you have any bug reports, feel free to report it to our mailing list. In the end, these are all the zip clients I built. So you have under this umbrella WebRTC clients, which are basically using Chrome engine. Behind it, it's the application server, Silk server, that does all the zip magic. And then you have native zip clients with a zip stack from A to Z that talk zip to the server, which are looking native, and they are native for each graphical environment, whether it's Windows, Linux, or Mac. Then it works in a web browser as well, because the client that I presented earlier, it's an Electron application, but basically it's a web page and can work. You can deploy it on a web page you have. You can change that web page, of course. Using that API, you can make any web page you want, actually, to achieve all this functionality. And of course, you have the command line clients. So with this, in total, I wrote 10 zip clients, completely different one from another. So a lot of releases. So I think as long as I'm alive, there are still zip clients around. So don't worry, okay? That's it.